Hello, can you hear me? Hello. All right. Okay. Last week we discussed this one of application of dimension analysis. Today we discuss the other uses, and I send you the table to complete. You can complete it and return to me. ඉවන්න කරලා මොන බලන්න හරි පැත්තේ බලලා ඉවන්න බලන්න හරි. කියන එක print out ගන්න යන්න ඕනේ නිකන් just ඔබේ නිකන් අංක දාලා දියන හරි table එක දාලා දියන හරි ඉවන්න. මම physically කරන්න චෝට් එක විදිහට ඔක චෝට් එකේ දාලා තිබ්බේ. Can't dimension formulas. But 80 of common you want to use those dimensional formulas to proceed the other parts, right? The other discuss करने वाले ये वाले dimension formulas use करने वाले technology see. Okay, we'll discuss the last day we discussed how can check the accuracy of a physical equation using this dimension analysis. And today we are going to discuss the other uses that we can derive an expressions given the relationship between the physical quantities, and also we can convert the units from one system to another system. You can find the dimensional formula of unknown quantity using this analysis also. Right? And write an example first right here. If an object that travels along a straight line, if an object that travels along a straight line with an initial velocity simple u, and uniform acceleration simple a, and uniform acceleration simple a, simple a, for a time simple t, for a time simple t, and attains a final velocity simple v, attains a final velocity simple v, and the displacement experienced by it is s. It is s. Okay, then write the equations relating to its motion are given below. Equations relating to its motion are given below. That's v equals u plus at. Okay. S equals ut plus half at square. That v square equals u square plus 2as. Both this equals u plus b divided by 2 multiplied by t. We will derive this in second unit. We are given these three four equations, right? So then write equation, check whether these equations are dimensionally correct or not. Check whether these equations are dimensionally correct or not. I will guide you how to do this. Normally we need to consider one by one. We consider this first one I will do, and the equation consider that b plus 2 plus 80, right? So we need to consider the dimensions of separate terms. First you need to consider the dimensions of u considered, right? Dimensions of v you can write. V, the first term, that is Lt minus 1 because it's a velocity. And then dimensions of u you can consider, it's also the velocity Lt minus 1. And then consider the dimensions of the At term. There are three terms, v, u, and At. Last day I given you that how to do it. So At, the dimensions of acceleration is Lt minus 2. The dimension of t, the time is capital T. The dimension of formula, right? You write this. The dimension of symbol like that. Introduce it like this. So by simplifying this t and minus 2 and plus 1, they simplify it's Lt minus 1. So according to this, you can see the dimension of this b, u, and At terms all are equal. That is Lt minus 1. So that means in this equation it satisfies the homogeneous principle or principle of homogeneity, right? So therefore, the dimensions of v, u, and t, that means the dimension of right side and dimension of left side and right side both are equal. So that means this equation is a dimensionally correct equation. And after you can write this dimensions of both sides of the equation is the same. And all terms both sides of the equation is same and all terms have same dimension. Same dimension. So we can say that it's dimensionally correct. Equal, yeah, right, right. Equation 1 is dimensionally correct. So that's the steps you need to write if someone asks to check whether or derive it as dimensionally correct or not. In these steps you need to write. And this first one I done for you. Then you can check whether these other equations, three equations, write the answer for like this. Okay? Check whether all the other components have the same dimension or not. Check करा Okay, that's S and U, that's S is the displacement. That is the displacement. U is the initial velocity. V is final velocity. A is acceleration, right? Right? U is the initial, V final velocity, D is indicates the displacement. These terms you need to know. Normally the question the given is indicate this like that. Wait to go through the other three. If you have any doubt, you can raise your hand and ask. And if you finish, also you raise the hand. Okay. Let's see now, right? Here, I'll just the second equation then. Let's try and make it. Second one, consider s equals ut plus 3t square. Okay, I'm considering the dimensions of these terms. Dimensions of s you can write. It's a displacement, so its dimension is L. And then dimensions of u theta. So that u is the velocity, Lt minus 1, and you multiply by the t is the time, sorry. The t and t minus 1 cancel. So it's the dimension of length. And then the half AT square term. That's the numbers has no dimensions. So you don't need to consider about the numbers. Before the equation, I'm telling you that we need to consider the dimensions one by one. Yeah, that's this equation. So we consider the now we consider the dimension of this. We are going to check these dimensions be correct or not. So then you need to consider dimensions of these all the terms there. This term, the ut term and the half AT square term. Now I'm considering dimensions of these terms separately, because if these all dimensions are same, all terms have the same dimension, only that equation is correct. Right? This has a dimension of length because it's the displacement. And ut term, u the velocity, dimension of velocity, and it's multiplied by the dimension of time. So by simplifying, we can say that is also similar to the and AT square term in here. This half will we don't need to take, right? Because the numbers and the log values or trigonometric values, sine, cos, tan, you don't need to consider the dimension of those, but only the physical quantities you need to consider. Keep that mind, right? The number, so dimension less constant is there. You don't need to consider what the dimension of the dimension less quantities. AT square term, only you consider it. Acceleration has a dimension Lt minus 2. And t square term we have dimension t square. Dimension of t is the time and square of it. This is t square and t minus 2. So then we cancel and it's also L. So it implies you that then dimensions of S, the dimensions of ut and ut equals dimension of AT square. All have the same value. So then dimensions of both sides of the equation is the same, and all terms have same dimensions. Then we can say that the equation, the second equation is also this equation. Second is also dimensionally correct. This statement you need to write after this, because if someone say like that, the equation is correct, it's wrong, right? If it is dimensionally correct, it may or may not be the correct equation. But definitely you need to tell it's the dimensionally correct. It's only dimensionally correct. Dimensionally correct equation, right? Because correct equation are dimensionally correct, but dimensionally correct equations may be a wrong equation. Okay, I'll go to the third one. Second one. Third equation. Okay, makano. Third one, consider if v square equals u square plus 2as. Now again consider the dimensions of the individual terms. Dimensions of V square, we consider first. The V is the velocity, so its dimension is LT minus 1. Now the square of this, so it's L square V minus 2. Dimension of U square. U is also the velocity, right? So its square of that is same as the previous one. Then the 2A's term, you don't need to consider 2. The 2 has no dimension. And acceleration has a dimension LT minus 2. And the displacement S has the dimension L. By simplifying this, you can get LT minus L square minus T minus 2. So there's three quantities or three terms they have in the same dimension L square T minus 2. Then therefore you can write is the dimensions of V square, dimensions of U square, dimensions of A's term. The sum writing is equal to A's term, or only A's unit, right? It's enough. Don't need to write that other term. Right? If you want a number at the end of it's not needed. A's term. So I equal. So the both side of the equation and all the terms have the same dimension. So it's a dimensionally correct equation. Correctly correct. You have to write like this. Okay. Quickly write and then what final one. Right? I will erase this and then the next one. Last equation. This. And this equation I'm writing it as AC equals. I'll multiply this as UTO2 that terms, then dimensions considered. So S3 considered, that is length L, and then UT term of we don't need, LT minus 1 and time is t. So it's fine. You can get Vt term is also similar to this because this is velocity and product of time. So it is also LT. So here it indicates therefore S, the dimension of S, the dimension of ut term, and the dimension of Vt. So this equation is also dimensionally correct. So for all lines, same way you write, right? And, I will give the different one. That's a different question from this. Right? And after this, that's another question, right? The second question, let's right. Show that the expression of velocity of sound. Show that the expression of velocity of sound expression of velocity of sound okay, sorry for the signals. Signals se kakak disconnect. This is row. This is okay. So that the expression of velocity of sound given by v equals square root of e over rho is dimensionally correct. It's dimensionally. Yeah, I'm given this E is that is the Young's modulus, the coefficient of elasticity. Right, it says Young's modulus. Young's modulus. Each has the dimension same as the pressure. You try this. Right, given that the dimensions measure is same as pressure. Pressure. If not, you need to get this dimension using the table I'm given. The table a complete gram each dimensions of pressure dimension last week we discussed. Then rho is the density. Rho indicates here the density. So you get the density. Okay. Density of the medium. Make it in the right side and left side. Left right dimension should equal to right side. Then it is dimensionally correct. To check the dimensions of left side and dimension of right side. That's enough. Okay. can write it as LH is the dimension of left side, the right is one is this, and right side. And if both are equal, so you can write it as equal and then it's dimensionally correct. If it is wrong, if the dimensions are not matched, so then you can say it's dimensionally wrong equation. Dimensionally wrong means it's wrong equation. So you don't need to write it the wrong way. You don't need to write it dimensionally wrong. You can directly tell that if it is dimensionally wrong means it's a wrong equation. But if it's dimensionally correct, we can't say it's a correct. Only dimensionally correct. Wrong way you can directly say it, because if an equation is a correct one, it should be dimensionally correct one. Tell me how we can show this. So for time wasting, I'm not going to do it. You can go through the questions given in the tutorial. This right side, there's a velocity, velocity. So it has a dimension that is LT minus left side. The right side, dimension of the right hand side is RHS. It has the dimensions of this over rho. I use this square root as a half power, or a half power, right? So then the dimensions of the elastic modulus or Young modulus. So it is m, the dimension of pressure, ml minus 1, T minus 2. Divided by the dimension of density is m, L minus 3. And the half the power of, by simplifying, m and m you can cancel. Here, m and m you can cancel. And L minus 1 and we get minus 3, 1 it will cancel. So L minus 2 it come up, then L minus, because you can simplify in this, you can get the L square will come then, new plus minus terms, power would have plus power is T minus 2. It's a half. They give a square anything, so you can take it like LT minus 1 square and the square root of this. So then the square power for that one, power multiplied by 2 into half, so it's still 1. So then the dimension remain this side is LT minus 1. Simple mathematical simplification. Power simplify करने के. So that's why I, when you, that's a mathematical, basic mathematics. Basic mathematics simplification simplification. So in the final we can write it LT minus 1. So therefore you can write this right side, dimension of the right side, left hand side of the equation equals to the right hand side of the equation. So dimensions are equal. Therefore, the equation is dimensionally correct. It's dimensionally correct. That is the way you need to write this. It's dimensionally correct. Is it clear how to do this kind of equations? If they are asking you to check accuracy of the equation or any formula given, So this is the way you need to write it. If there are more terms, let's say there are two terms in this kind of equation, because it's right hand side and left hand side only. But if there are more terms like sum and the negative, that's a subtraction. So then you need to consider the dimensions of all the terms, and then all should be equal. It's wrong. But raise your hand if you finish up to this point. If you have any question, you can ask, right? ඔහොම ප්‍රශ්න තියෙනවා නම් අහන්න නැත්තම් hand raise කරන්න මාරෝගේ hand raise button එකක් තියෙන click මෙතනට නිකන් ඉවර නම් ලියලා then we can move to the next. Still writing. ඉවර නම් කියන්න hand raise කරන්න. I'm waiting to finish the writing. එහෙනවනේ මං කියන එක. මොකද මේ සමහරවල් මයික්ස් එක එක සමහරවල් ඇහෙන්නේ නැති වෙන එකයි මම මේ නිතරම අහන්නේ මේ. ඒගොල්ලෝ මොකක් හරි රෙස්පොන්ස් එකක් දක්වන්නේ එහෙනවද නැති කියන. මේ ඇහෙන්නේ නැත්තම් කියන්නේ නැත්තම් කොච්චර මෙතන කියනවත් වැඩක් නැහැ නේ මේ ඇහෙන්නේ නැති. මොකක් හරි චෙක් කරන්න මේ සිස්ටම් පේජස් එහෙම තියෙනවනේ ඔය. මෙතරම් වෙරිෆයි කරගන්න වෙනවා. එහෙනවද නැත්ද මොකද? Okay. Then we got to the second usage of dimensional analysis. This is important one, most important one in this dimensional analysis. That is the derivation of equation by the method of dimensional analysis. So we can use this method to derive the new relation among physical quantities. Then write the second application of dimensional analysis. Write it as second one. Derivation of equation by the method of dimensional analysis. Second one. Equations by method of dimensional analysis. Right? Set up. Okay, then right under this, the dimensional analysis can be used. Dimensional analysis can be used to derive new relation. Among physical quantities. among physical quantities. Okay, then idea, the homogeneity principle of dimensions, homogeneity principle of dimensions is powerful tool to establish, is powerful tool to establish powerful tool to establish the relation among various physical quantities. Relation among various physical quantities. Okay. Under this method, we need to know some mathematical trick. I already discussed this under that basic mathematics part, so I also given here also. If we can say that this is the quantity y that depends on the x, let's say the quantity y, it depends on the x. So in mathematically, we can relate this to the y proportional to the some power of x. Power a, let's say a is any number or any value, it will be a fractional value also, right? In mathematically, we can write that statement. Next statement, you can write that is a temperature. It depends on the volume. Volume of a gas is depends on the temperature. So then we can write as a volume proportional to the some power of the temperature. We don't know that power. We can find it. These powers we can find using this dimensional analysis. That's the way we can relate this equation. We can get only the relationship, but we can't say about this proportionality constant because it's a proportion. When there is a proportion, you can convert it to the equation using the constant. So we call that proportionality constant we introduce there. Then you can write it as equation like this. In dimensional analysis, we can find what should be the power of this A, but we can't find this A, K. The proportionality constant we can't find. If you want to find that proportionality constant, you need to do an experiment then. That is the experimental method we need to introduce there. So then this proper equation you can find. A dimensional formula you can find using this dimensional analysis. But in these kind of cases, normally in the questions they given this proportional constant, then you can write the correct equation. So method. It mathematical relation if someone say that the that's component y is depend on the x and z and another quantities, then you can write it like this proportional to the x to the power a, z to the power b, and another one, let's say that is w to the power c y. Likewise, you can write the this this will call the that's a index equation, because we writing the other they were indexes here. You can write this formula, and then you need to find dimension analysis. We can use to find this ABC, these powers, dimensions we can find. So then we can derive the equation that way. So easy with you see. It's okay. We'll go through the right. Okay. Right there. First, right under this, you can write there. As a note, you can write right. Under the right first. If if the quantity y, if the quantity y depends on x, if the quantity y depends on x, can be expressed as the y is proportional to, expressed as y is proportional to some power of x. Y is proportional to some power of x. Right. Then it can be written as that's y proportional to some power of x. Hence you can write that y equals k x to the power a may be any value. Right. Yeah, I'm writing a any number, maybe any number, any fraction, any value. And where k is, right, also, yeah, k is the proportionality constant. Oh. Proportionality constant, right? So k has no dimension. The dimensions තියෙන ඒවා කරන්න අමාරුයි මේක. මේ method එක කියන්නේ dimension නැති constant. No dimension. K has no dimension. So this way you need to write this for different cases also. Another example I can say, that's another example. And if I take a different one, A depends on B, C, and D. One can say like this. Then you can write this, that's A proportional B to the another mode, then in any power, let's say alpha, and C to the beta, D to the gamma. Alpha, beta, gamma are constant values. Constant values. They have no dimensions. And in this way, you can write this as K equals B to the alpha, C to the beta, and D to the gamma. This method you can write this. That's the equation. Then we alpha, beta, gamma will find using dimension analysis. You can write this equation also, and after that you can write, yeah, dimension analysis can be used to find the exact value of these powers. Write the dimensional analysis. values. Find exact values of alpha, beta. Current common gate column. So this is the way. Yeah, A you can find using the dimension analysis. If you know the quantities they given. Is A basic quantity we know not quantities, so we can do this. The example and first then we got to do this by step. I will get the example and then we'll discuss how to do this one by one. Step by step we do this. Right? And also you need to know that alpha beta constant values and also they are real numbers, right? Yeah, also help. The A may be any number. You can write it as not any, it is real number. Should be a real. So far I mean. You can imaginary කියලා ඒවා මෙච්චර තියෙනවා. ඒ වගේ එකක් එන ඒවා අපිට හොයන්න බෑ. Okay. Then right. Erase this. Right. It's an example. Example like this. Right. Assume that period of time. Assume that the period of time. Let's make a write a capital T. Assume that the period of time, capital T, of a simple pendulum. Period of time, capital T, of a simple pendulum. Pendulum depends on the following physical quantities. Following physical quantities. Okay, this is the physical pendulum. Game again. The lateral game oscillates. So time period is time period can so that's time taken to complete one oxidation. One oxidation means if we starting from here, goes to this side and come back, goes to this side and come back to the initial position. There is one oxidation. One, two, like this. Taken time taken to that one complete one oxidation is called the time period or periodic time. Okay, this you know the following quantities. You can write the first one. This quantity is length of the pendulum. Length of the pendulum. That is a simple L. Second, mass of the pendulum bob. Mass of the pendulum bob is pendulum. That is simple M we use. And third one, gravitational acceleration, simple G. Simple G. Okay, I'm given here that time period of the pendulum that depends on these three quantities: length of the pendulum, mass of the pendulum, and gravitational acceleration L, M, and G. So we are going to discuss how to derive the relationship between these quantities. Then after that you can write then derive the relationship among these physical quantities. Derive the relation among these physical quantities. Then we'll derive this. You want to control this S G depends on L, M, and G. Okay, that G you can write G depends on these and M. G depends on these three quantities M and G. You can write this A proportional mathematically L to the power M to the power P, let's say, G to the power C. So A, B, C are real numbers. Real numbers. Okay, real values. So then we can write this T, K, L to the A, M to the P, and C. Here K is the proportionality constant. Without dimension. You need to know. And then I will give the value of this K because K you need to find. Because we can't find the K using dimensional analysis. We need to write. This is the equation now. Now ABC values you can find using dimensional analysis. Okay. You can consider this as the index equation. This is the index equation, right? This is index equation. Okay. You can write up to this point. you are what this is. And then write considering dimension of both sides of this equation in this equation. Right there, considering dimensions of this equation. Index equation. We call index equation because it is the indices of the organic equation. That's the dimension of the left hand side. That's the term is called the t, the time period. So it has a dimension that is this time dimension t t so that is t to the power 1 actually. So this dimension you can write that is m to the 0, l to the 0 and e to the 1 m to the 0, l to the 0 only one. Last day I given you that how to write. And then consider the dimension of right hand side. There are these terms. L to the A, M to the B, and G to the C. K is dimensionless. You don't need to consider. Now you can consider the dimensions of other terms, other quantities. K has no dimension. L is the length. Length has a dimension L. So it's to the power A. And M is the mass. The dimension of mass is M to the power B. G is the acceleration. Its dimension is LT minus 2 to the power C. Now simplify the indices. You can, because this is M is only here, so you can write it as M to the power B only. First term L is there, L to the power A, and here also L to the power C is there. These powers are then at come up base you can add the powers. So you can write then L to the power A plus C then. L to the power A here, L to the power C here, you can add the powers. And here time t to the power is minus 2 multiplied by C, it is t to the power minus 2C. Okay, now you can write this right hand side. The dimensions now m to the b, L to the A plus B, and t to the minus 2C. And in left hand side, m to the 0, L to the 0, and t to the 1. Then what we need to do, if it is dimensionally correct equation, we are going to discuss, we are going to derive. So these dimensions we can equal. The dimensions of m should be equal to both sides. Dimensions of L should be equal in the both sides. Dimension of time should be equal in the both sides. So then you can equate in this, you can find these ABC values. You can get the equations to find this dimension. Okay. And there is this for what? After this point, the next step you can write there. Equating dimensions of m or indices of m. Write the dimension of m And then you can write in right hand side, its dimensions is b, and in left hand side, its dimension is 0. Now is 0. The b equals 0. This is the first equation you can get. And then equating dimension of L length, right? Here length dimension A plus C. And the other side, right hand side, its dimension is 0. A plus B equals 0. That's the second equation. Then equate dimension of time. So in this side is 2 minus 2. Other side it's equals to 1. Third equation. Then you can get the three simultaneous equations. There are three unknowns. So three simultaneous equation, you have three unknowns. Then you can solve this simultaneous equation to find the unknowns. That's where you can get. Okay. Right after this point, after this one, you need to write this. I will erase then this all. Right here. Right. I'll erase this one, right? No? It's fine. In right, solving this simultaneous equation, we can say then b equals 0. Here you can see the second equation, a equals minus c, b equals 0, and 1 because if I can't do any second equation, you can write that a plus a equals 0 means that is a equals minus c. And third equation gives you that c equals minus half. If a equals minus c, then a equals plus half. Right. So then you can write this a equals plus half, b equals 0, and c equals minus half. ABC values you can find. You can put your pen under the pen under the directive. You can get it directly. You can write. So therefore, equation now we can substitute t equals k times That is L to the power A, that's half. M to the power B, that is 0. And C to the power minus half. 0 power means that is 1. Or any value, 0 power of any quantity, it's 1. So that means this equation M is not included. And අපි දැන් කත්තට එක M මත depend වෙනවා කියලා, if you assume that it depends on M, but actually it's not, doesn't depend on the M. M මත යා depend වෙන්නේ නැහැ. ඒ කියලා M වෙන්නේ නැහැ මේ equation. M to the power 0 means 1, M නැහැ. So we can write this as then K times it's L to the half and minus powers is our equation have plus powers so yeah. Minus power එක යටට දානවා. So G not C is G කියලා equation එකක්. ඒක යටට දානවා. ඒක minus plus. Half powers means is the square root. So then you can write this as the equation T equals K times square root of K half powers තියෙනවා. ඒක දෙකම square root එක ඇතුළට දාන්න. L over G. This is the equation. Right? Here you need to know that the value of proportionally constant K cannot be found by the dimensional analysis. Should find experimental. Experimental come. So here K is given as 2. Here K equals 2, 5. That is experimentally we can find. Therefore, the relationship, original relationship between these two, T equals 2, 5, square root of L over G. So this is the equation you derive. It's the way you can derive the equation among physical quantities. These steps you need to follow for any. You don't need to write this all. This may be value same or question again main steps dimension compare dimension apply both side. In index equation you need to write the index equation, then consider the dimension of the both side and equate the dimensions of different quantities, and then find you can solve the simultaneous equation and find these values of the powers or indices, and then substitute and get the final relation. Okay, is it clear how to derive it? Are there any doubts? Is it clear? Clear now? Hand raise karma. So Sarban theory try. ක්‍රමය හැබැයි තොස් එකක් තේරුනේ නැතුන කෙනෙක් දැන් ලොස් වෙන සමහරලාට යනවා කොහොමරි පානික ස්ටේබල් සිග්නල් සමහරලාට මගේ සිග්නල් ලොස් වෙනවා ඒ හින්දා මම මේක recording එක දාන්නේ හදිස්සිය හරි ඔයගොල්ලන්ට කොයි විදිහට ලොස් වුණොත් you can go through it and you can check what recording එක දානවා කියලා අර class එකේ ඉන්න නැතුව ඉඳපුවා ගොඩක් අය live ඉඳලා ඉගෙන ගන්න බෑ so if you have any doubts or anything you can ask anyone on live අහගන්න පුළුවන් දැන් ගොඩක් වෙලාවට මේ ළමයින්ට ගොඩක් වෙන දෙයක් තමයි මේ recording එකේ තියෙනවනේ කියලා පොඩ්ඩක් තියාගෙන ඉන්නවා ඒ බලන්නේ ඊට පස්සේ වෙලාවක බලන්නේ බලන්න නැතුනම අතපසු වෙනවා ඊට පස්සේ දිගටම රෙකෝඩින් කොට ගියේ ඊපස්සේ අර පොත් බලනවට වඩා වෙන රෙකෝඩින් බලලා නෝට් ලියා ගන්නත් වෙනවා නෝට් දැන් පොතේ ඔක එකපාරේ ඒ වෙලාවට ලියාගත්ත පස්සේ ආයෙ නෝට් එක අමතක කරන බලන්න ඉතරයි තියෙන්නේ දැන් රෙකෝඩින් තියා ගන්නවා කියලා කියන්නේ රෙකෝඩින් එක බලලා ආයෙ නෝට් ලියන්නත් වෙනවා ඒකට ඒක very difficult නේද ඒක ඒ වගේ එකක් ගොඩක් ළමයින්ට පාඩම් ගොඩාක් අතපසු වෙනවා ඒ හින්දා අපේ ඒක ඔයගොල්ලෝ මැනේජ් කරගන්න බලන්න ඉතින් කොහොමද ලයික් කරන විදියත් එක්ක ටිකක් මාරයිට කාදියන්නේ නැහැ ඉතින් අපිට ඒකට ලොකුට කරන්න විකල්පයක් නැහැ නේද ඉතින් ප්‍රශ්නත් එක්ක රටේ හරිනේ ඉතින් ඉවරයි නේද තව එක්සැම්පල් බලලා ඒ ප්‍රාණ ටිකන බැරි එක්සැම්පල් එකක් කරනවානේ හොඳයි එකක් ලියාගමු යන්න මෙහෙම the speed of a particle moving in a circle speed of a particle moving along a circular path depends on the following quantities depends like the speed of the particle the mass we can write the following factors that's first one write the mass of the particle is simple m and second one radius of the circular path of the circle I am writing in short as r okay sorry little bit question should be changed not the speed of the particle you can write instead of the speed of the particle you can write the acceleration of the particle but change it as acceleration the acceleration of the particle moving the other part is okay Not the speed, you can write the acceleration of the particle, simple A, right? Simple A. The acceleration of the particle depends on the following quantities, right? The mass of the particle M, radius of the particle R, and last one is the speed of the particle. Speed of the particle. There is V. Okay. Sorry for that. That's A depends on these three quantities. M, R, and V. By taking the proportionality constant equals to 1, by taking the proportionality constant K equals 1, derive the relation between these quantities. Derive the relation between these quantities. Right. Now you go through this and then give me the relation. Okay. You can take this as that's A is proportional to the M to the sum 1 and sum 2. You can get any power, right? I mean, x, y, z also you can write R to the I and B to the Z, B to the Z, right? X, Y, Z, give me the values of x, y, z. I'll give you the 5 minutes to do this. And also after tutorial, with the tutorial, I will give more exercises. So just you do this. If you have any doubts or any points you need to verify, you can ask. Yeah. බලමු මොකක්ද ආවේ values අපෝ values ටික කොහොමද equation directly replicated equation but if you moving in a circular path, right? Particle is there, requires the velocity v, let's see the radius r. That's acceleration towards the center. That's acceleration I'm given right. The mass of the particle is here. That acceleration given you that this depends on these quantities. You can write this as m to the power x, r to the power y, and v to the power z. So here you can write as a constant m to the x, r to the y, and v to the z. So k is a constant, right? Proportion to constant. I'm writing it as this constant because that k of the value given as 1. This question they be given this value, right? Then considering the dimensions of the right hand side, writing the right hand side dimensions, sorry, left hand side first, dimensions of acceleration, that is lt minus 2. I'll write this as the m to the 0, l to the 1, and t to the minus 2. Then I'm considering the dimensions of right hand side of this equation. At the side, we don't need to consider the k now. So m to the x, r to the y, and v to the z, the dimension of these things. And the dimension of mass you can write is m to the x, and the dimension of radius is l to the y. And dimension of lt minus 1 to the z. M to the x then, and L to the y here, L to the z here, right? You can multiply this. So then L to the here y, and is it y plus z, and t minus these other dimensions of the right and left hand side of this equation. Now we equate in the dimensions of k. You can write as equating dimension of. Here you don't need to write it. I'm not writing in short form. You can write as the dimension of the dimensions of m. You consider. Then we can write as x in right side is already equals to the power of m in left side is 0. And by considering the dimension of L, the right side is y plus z, left side is y1, and it's t. Right side it is minus z, left side is minus 2. According to this, you can write z equals 2. Z equals 2. And then z you can substitute in this y plus 2, that's equals to 1. Then y equals minus 1. Okay. By solving this, you can write then x equals 0, y equals minus 1, and z equals 2. Then this your equation a, the value of k is 1 here. You don't need to do it. M to the 0, r to the y is minus 1, v to the z is 2. 0 power omitted, and then r to the minus 1 powers goes to the denominator as plus powers. Then you can write this equation as v square over r. This is the equation. That acceleration doesn't depend on the mass. That's why this mass will not come to there. If it depends, you can there should be this value also. That's the way you find it, right? Is it clear up to this point? Right, thank you. Then finish the writing, let me know. I will go to the next one. Third, we can use that method to convert a physical quantity from one system to another system, one unit system to another unit system. There's not much frequently used application, but you can do. I'll erase that. Finish the writing. Raise the hand if you finish the writing. Right? Only toggle me කරන්න ඉතින්. නා හරි ගිය. හරි කියන දේ වැරදුනා අද කොහෙද යන්නේ. මේව තමයි කියන්නේ මෙච්චරයි ඔය කියන්නේ. ක්වෙස්චන් එකක් විදිහට දුන්නොත් අර බැලුවට අරන් ගිය ගොඩක් ලියන්නේ යන්න ඕනේ. When doing this way solve. Finally got the answer. Okay, third application is conversion of a physical quantity from one system to the other. Conversion of physical quantity from one system to the other. Conversion of physical quantity from one system to other. Okay. Then right now, again, dimensions of one is naming, but dimensional analysis we can do it. Right? And then write the dimensional formula. Dimensional formula is useful. Dimensional formula is useful to convert the value of physical quantity. Convert the value of physical quantity from one system to the other. From one system to the other. Right, the physical quantity is expressed. Physical quantity is expressed as product of numerical value and unit. Already discussed. Physical quantity is expressed as product of numerical value and unit. Right, in any system of measurements, this product remains same. This product remains same or remains constant. This product remains constant. By using this fact, we can convert. By using this fact, we can convert the value of physical quantity. Value of physical quantity from one system to the other. From one system to the other. Let's discuss this with an example. You can write this as example as a question, right? Convert 1 joule to erg, right? ERG, erg. Erg is the unit of energy in CGS unit system. write as a joule is unit of work in SI unit system. Joule is SI unit of work. Right, in SI unit system. This is a unit system. System means SI unit system. That's erg is CDS. Now we are going to get the relation, but how much erg in joules, or how much joules in erg? So we can write in dimension of work in a SI system. SI, right? That is writing W is work with W1 in the one indicator is a this is SI system, right? So the dimensions in this SI system we can write as M1, because you know the dimension of work is M L square T minus 2. M1 L1 square T minus T1. The one we use that is in SI system. The taken two system now we consider. Two system, these dimensions we consider that different because they are in SI system. That's the mass is measured in kilogram. That's the dimension in the, related to kilogram. But in CDS system, the mass measured in grams. So its dimension relates to gram, not to the kilogram. That's why I'm writing is M1 L1. That's for the CDS system. I take and it says I'll take is M2 L2 T2 like that. Right. Write the dimension. The dimensions are not different in both the systems. It's the same. Units are different. Dimensions of work. CDS system. CDS you can write that is W2 M2 L2 square T2 dimension is same way you can write according to the system that quantity consider කරන unit එක තමයි වෙනස් වෙන්නේ. So the units වල powers විදිහටනේ dimensions කියන්නේ. ඒකයි this is the units of powers of the units in this system. Powers of the unit in other system. Physical quantity we can write as any system. Physical quantity is the, remember the numerical value multiplied by the unit. Number multiplied by unit. So then the in SI system the number is N1, the unit is the U1, it's the dimension of this unit. It should be equals to any other system also. Number multiplied by the unit system in that system. A system make a number multiplied by the unit used in the other system. Dimensionally they correct because dimensions of any system is a constant. Dimensionally system wise dimensions are not changed. The unit dimension of this unit, so the correct is in one multiplied by the dimension correct in the system as M1 M1 star E1 to the power minus 2. M2 L2 star can use in this. right? So then you can get the relation between this n1 to n2 ratio. Here this is only in this variety 2 to the 1, that's equals, you can write me better than medium e, right, m1 to m2, and here l1 to l2, star of that, and e1 e2 minus 2. You can write it in this format. Just insert the dimensionally. This we can write. But in these two systems, you need to know about these conversions. It's in SI and CGs. SI system and CGs. That's mass. The M1 I mentioned there, that's kilogram. CG system, this M2 mentioned, that is gram. So according to this, you can say that M1 that's equals to the 1000 of M2, and L1 is meter, L2 in this system is centimeter. According to use, you can write it L1 is 100 times of L2. Conversion is enough. T1 seconds, T2 is in seconds. So in these two systems, the T time is taken as same way. T1 equals T2. Right. So then M1 to M2 ratio, that is equals to 1000. You can get. So I will substitute there. N2 or N1. M1 is equals 1000 times of M2. Divided by M2. Then L1 is 100 times of M2. Square of that. T1 equals T2. So here you can write T2. We cancel. M1 M1 cancel, and you can write now. So here M1 M2 M2 cancel, L2 L2 cancel. So this is 1000. This is 100 to the power 2. And make comma thicker. This ratio is given you that value is 10 to the 7. So 10 to the 4, 10 to the 3, total is 10 to the 7. N2 to N1 ratio is then equals to the may relation system you need to know about this, right? System I wrote this all, and now I'll just stop part. After this point, you can write then. Let's I'll finish the writing. N2 to N1, that's equals to 10 to the 7. This gives you that N2 is equals to 10 to the 7 times N1. Yeah, the N1 they given as 1 joule. So then N1 is 1. N2 is 10 to the 7. So it gives you that then 1 joule, that's equals to the 10 to the 7 erg. So that is the conversion between these two. 1 joule is equal to 10 to the 7 ergs. So 1 erg is equal to 10 to the minus 7 joules. Then other way. You try conversion. But in other systems also you can convert like this. This conversion, you don't worry about much about this conversion, because මේ වගේ conversions අපිට ගොඩක් වෙලාට එනවා අඩු. නෑ ඒක අපි දැන් මේ systems පාවිච්චි කරන්නේ. Theoretical තියෙන ඉඳන් මම කියලා දුන්නේ. එකකින් කලං හදන්න එන ඒවා බලන්න දෙන්නේ නැහැ. ඒකට ඉන්න බලන්න ඉතල ලොකු weight එකක් දාන්න යන්න එපා. ඒක පාඩම් කරගන්න කියලා. just දැනගත්තා නම් Okay, you finished, right? ഇവരതില്ല. Hello. ഇവരത് എനിക്ക് ഇത്രയും 10 റസ്ബെറി the dimensions and answer together my key so for effects you need to know that some physical quantities they are having units but no dimensions. Some physical quantities are there, they're having no units and no dimensions. So like the refractive index, so no units, no dimension, and coefficient of friction, further mention this thing and you go. The next part we'll discuss in next week. Then I will send you the. You can go to complete that table given and then send me, and I will check there's some mistakes and I'll correct it and send you again. First, I will send another tutorials to you. And today night to tomorrow morning, I will send you, and then go through this one because it's some questions similar to the examples we discussed. And go through this and try to do it yourself. And if you have any doubts, you can send me and I will guide you on how to do it. Well, if we can start class next week physically, then you can come with the answers, then I can explain, I can discuss in the class. I'll send you the tutorial. That's hard copy of the tutorial give that the physical class, right? I'll stop the class for this point today. Do you have any question and doubts to ask? Question is clear. All clear, then let's stop the class, right? Okay, then see you. Bye.